Okay, guys, welcome to the 5.1 notes, rate of change, and slope. So our first vocab word here is rate of change. Okay? So, that's just awful, but you guys know what that means, rate of change. Okay? So, as we've been talking about kind of in chapter 4, rate of change is just how fast something is growing, or it's just how fast something is changing. Okay? So the rate of change shows the relationship between two changing quantities. Okay, so here's kind of the formula. It's the change in the dependent variable over the change in the independent variable. Okay, so as we jump into problem 1 here. Okay, so marching band. The table shows the distance a band member marches over time. Is the rate of change in distance with respect to time? Okay, so is it distance with respect to time constant? Okay, so is it the same? Okay, what does the rate of change represent? Okay, so what we want is distance with respect to time. Okay, so it's going to be distance over time, and that'll be our rate of change. Okay, distance with respect to time. So distance is our dependent variable, time is our independent variable. Okay, so dependent variable, independent variable. Okay, so basically all we're going to do is we just have to see if it's constant or not. Okay, so we pick our first two numbers here. So it's 520 minus 260 over 2 minus 1. Okay, so it's the change in our dependent, the change in y. So 520 minus 260 over 2 minus 1, the change in x. Okay, so as we plug that in, we get it's 260 over 1. Okay, now we want to do it for our next set. So we have 780 minus 520 over 3 minus 2. Okay, so 780 minus 520 over 3 minus 2 is 260 over 1. And then finally we want to see if it works for our last set. Okay, so we have 1040 minus 780 over 4 minus 3, and yep, you guessed it when I do the math, okay, that's 260 over 1, okay? So what the rate of change is telling me, and what this is basically saying, is that for every minute that passes, okay, my marching band member is going to go 260 feet, okay? And so basically this is the exact same thing we've been doing, is just saying, oh, 260, 260, okay, and 260. Now we're just putting it in things, okay? So we're all three at 260 over 1. So yes, the rate of change is constant, and, okay, it's 260 over 1. Okay? So that's rate of change. That's just kind of a quick minor idea that we're going to talk about. That'll lead us into our main idea of today's lesson. So of course, obviously, our main idea, what we've been talking about already, which you guys have memorized already, is slope. Okay? So we all know that slope is rise over run. Okay, how fast we go up and down over how fast we go side to side. Okay, so I want you to circle this, highlight it, underline it, whatever you got to do. This is our formula for slope. Okay, so rise over run. When we rise, we're on the y-axis, so it's change in y over change in x. Okay, so it's the change in y over the change in x. Okay, so let's jump right into slope. So, if you remember from previous years, once again, slope, rise over run. Okay? So how fast we go up or down via how fast we go side to side. So, on my first graph, I have this point here, and I have this point here. Well, I'm going to rise first, so I rise 1, 2. Okay? So I rise 2 over how far I run, 1, 2, 3, so 2/3. Okay, and slope is super easy when it gives us a graph. We can just count it with our finger, and we've been working on that, and you guys should know how to do that. Okay, remember, it's rise first over run. Now on our next one, we start here at this point and go to this point. So now we're going to rise 1, 2, 3, 4. Okay, however, we didn't really rise, did we? We went down. Well, how do we represent down on a graph? Well, that would be -4 over how far do we go, right? 1, 2, 3, 4, 5. Okay, so down 4 over 5. Okay, so we rose -4, which basically means we went down 4, then we ran 5. Okay, and hopefully that makes sense. Hopefully we get the idea of counting with our finger. Okay. Finally, problem 3. Look, we're almost done for today. Okay, so once again, what is the slope through the line of this? Okay, this is where your formula comes in handy. Because there's not a picture, we can't really count it. So remember, our formula is y2 minus y1 over x2 minus x1. Okay, so we have x1, y1, x2, y2. Okay, so I have -2 minus 0 over 3 minus -1. Okay, so once again, I label my points, x, y, x, y. It does not matter which one you start with. I would recommend just going in order from left to right. Okay, so x1, y1, x2, y2. Okay, then I plugged into my formula. So y2 is -2, y1 is 0, x2 is 3, x1 is -1. Okay, so -2 minus 0 gives me -2. 3 minus -1, well, that turns into a plus, which is 4. So my slope is -1/2. Okay. Once again, same exact thing on 3. Okay. So we have x1, y1, x2, y2. Okay. Then I plug directly into my formula. Okay. So it's -1 minus 3 over 4 minus 1. Okay, so I took my points because there's no picture. Okay, if you want to get graph paper, graph it, and then count, that's fine. I would just recommend, because the formula is not that bad. It's just a simple formula that we're plugging into. So 1 minus -3 is -4 over 4 minus 1 is 3. And that's all I do. My slope is -4/3. Okay, I want you guys to try problem 4. Okay, we have, once again, these 2 points. Okay, get this point here, and this point here, and this point here, and this point here. Okay, I want you guys to try to see if you can figure it out. Okay, just a heads up, these are a little weird. Okay, they're a little trick to them, but hopefully you guys can figure it out. Okay, so I want you guys to try problem 4, and once again, if you have questions, put your questions on there. Hopefully this was a quick enough video, because hopefully we still get slope. Okay, so once again, make sure to watch it, make sure everything's filled out, or else you're going to have to sit outside, and that's super awkward and embarrassing. So, yeah, have a good day, guys.